So in this exam style question, they ask us to, on the axis below, sketch the current voltage characteristic for a filament lamp for current up to its working power. Now we saw this graph earlier, but I really want us to just reproduce this right now in this exam style question. The very first thing we need to do is kind of talk about what's going to be on the axes. So they say a current voltage graph. That means we're going to have current on this axis and voltage on this one, which I've labelled like this. The next thing we need to do is remember that for a filament lamp, its resistance increases as the current through it increases. In other words, it becomes harder and harder to pass a current through it as the current you've currently got in it increases. So for a certain current, as that current increases, you have to have a higher potential difference to see the same increase in current. What that means is we're going to have a graph that kind of tails off, starts to flatten out. Remember that's because in a current voltage graph, what you're measuring is really the gradient of your graph is 1 over your resistance. So as your resistance increases, the gradient of this current voltage graph will decrease, and so you should flatten out. So let's draw that on now. So we've done that here. The idea is here it's flat, and then it kind of goes up and starts to steepen a bit, and then it's a bit flat, it's a bit more of a straight line, and then it starts to flatten out again as our current increases. So this is the kind of graph we get. Yeah, you could have done this with varying degrees. You could have exaggerated it so it's basically mostly curved entirely, or you could have kind of made it more flat. The key thing is I had to see that it was kind of flattening at the beginning, and then its gradient increases, then the gradient decreases here. And this is the correct graph. Remember, this is because as the temperature increases, the resistance increases as well, and therefore it becomes hard to get a current flowing. So in the next question, they ask us to, and we've been talking about this already, they ask us to state what happens to the resistance of the filament lamp as the current increases. And remember, as we've been saying all the time, the resistance increases. That's what we're seeing from this graph here. Here we see the gradient decreases, which is the same as saying that the resistance increases. So let's write that down. So the next thing they'd like us to do is to state whether a filament lamp is ohmic or non-ohmic conductor up to its working power. We don't need to worry too much about what that exact last sentence means. It's more just asking whether it's ohmic or non-ohmic. So what do we say? Well, the very first thing we do is just look back at this graph. Remember that an ohmic conductor is something where the resistance is constant, or equally the voltage and the current are proportional to one another. The voltage is proportional to the current. From V equals IR, remember seeing? If we see it like that, this doesn't mean that it is proportional so long as the resistance is constant, in which case this is a proportional equation. We can write V is proportional to I. It's not the case if the resistance isn't constant. So it's basically two ways of saying the same thing. So we need to realize that straight away, it's certainly not the case that voltage or the current is proportional to the voltage, because as we see here, as the line is flattening out, we have a different value here for the proportion between the relation between I and V as we do here. It's a curve. It's certainly not a straight line. Because this is a straight line, it's not a straight line, we see that resistance isn't constant. So either of those things are equivalently saying the same thing. So we'll just write it down. We certainly see that it's not ohmic.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.